Logarithmic expressions, like exponential expressions, are used throughout math and science. A logarithm is the inverse of an exponential function, which means logarithmic and exponential expressions undo each other as long as the base is the same. We see this idea throughout math, where multiplication undoes division, for example, or subtraction undoes addition, and we use that idea of undoing to help us solve and simplify expressions. The same concept applies here, where logs and exponents undo each other. And for that reason, you'll notice that the log rules are basically the opposite of the exponent rules. If you need a refresher on exponent rules, I will include a link below of our other tutorial so you can see what I mean about how the rules are basically the opposite of each other. There are 7 log rules, and keep in mind that each of these also work for natural log, which is written as ln and has a base of e. So in each of these cases where you see log, the abbreviation for logarithm, you can also replace that with ln, the abbreviation for natural log, and as long as it's consistent on both sides and all the way through the problem, then the rule applies. First, let's go through the expanded and the condensed forms of logarithmic equations, especially because these are where you're going to see a lot of similarities with the exponent rules. In the first one, if we have log of some base of x, plus log of some base of y, and we want to condense that, we can write it as log of that base, x times y. If we have log base b, x, minus log base b, y, so the bases are the same and you're subtracting, we can condense that as log base b of x divided by y. Also, if we have a coefficient in front of the log, we can bring that up as an exponent inside of the log. And note here, I just want you to make sure you understand how to say these. So I gave you this example. If we have the log bxy, like I have here, the way that we really say that is log base b of x to the y power. It's important that you know how to say these verbally as well as how to write them. In addition to these 3 expanded condensed forms, we also have 4 more rules involving logs. One of them is log of any base, it doesn't matter what the base is, of 1 will always equal 0. We also have this idea that log base b of b to the k, so you see log base, those will cancel out and the k will drop down and simplify to just simply what that exponent was. The same rule applies on the next one. If I have base and in its exponent log base k, the base simplify, that k drops down. And then back when I was telling you about how logs and exponents undo each other, I am referring to this idea here where I can interchange between the two. I just want to remind you that when you're going back and forth, you always start with the base, and I'll show you what I mean. So there's this idea, I've heard some people call it frog on a log, where if I start with the base, I can jump over and then bounce back. So you see I went base k equals x, which is exactly what I have right here. And like we said, logs and exponents can undo each other, so if I'm given the exponent and I want to make it go back to log, I can do the same thing. I start with the base and I bounce back. You see I had base x equals k. Log base x equals k is what I have here. So you can go back and forth between the two using this jumping idea. All of these will be much easier to see with some examples, so let's go ahead and do a few together. In each case, you want to make sure that you look at the directions. Here it's telling me to expand, not simplify, not solve, but just to expand. So in its condensed form, I want to expand it so that it has multiple logs spread out. First, I see that the x squared is being multiplied by y, so I'm going to use my expand rule and change that multiplication to addition, giving each its own log. I also see x squared here, and I'm going to use the last condense expand rule that says that that squared can come in front as a coefficient. So this can be written as 2 log 3 of x plus log 3 of y, and this is expanded. As you know from all my tutorials, I usually start out easy and I get more complicated, so you're going to see I'm going to start ramping it up a bit. Here we have log of some base, we don't have to have a number there, of x times y over z. So let's take care of the x times y first, just like before. I'm going to make that as an addition. And because that's all being divided by z, I'm going to subtract from all of this log base of z. That's it. Z's in the denominator, so it gets a subtraction in front of it. This next one's pretty similar, just a little more complicated. Just like before, I'm going to take care of the top first by changing this into addition. And then I'm going to subtract what's in the denominator, but since there's multiple things in the denominator and they're being multiplied together, I'm going to use parentheses to distinguish that all of that is down in the denominator. There is a rule we learned that log base of that same base to a power simplifies out, so I'm going to recognize that this 8 is the same thing as 2 to the third. So if I have log base 2 of 2 to the third, the log 2 simplifies, and I'm left with simply 3. Here I see that I have an exponent on this 3. I know what to do with that. We've seen that in the problem before. I'm going to bring that out into the front. And I'll just go ahead and bring it down here too, since there's really nothing else I can do with it right now. Aha, do you see another log 2? This is technically to the 1 power, so the log 2 simplifies. So I'm going to have minus 1. And I can't do anything with that log 2y. Because of this minus right here, it needs to distribute to everything on the inside, so I'm going to rewrite this with each of these having a minus in front of them, which makes sense because they were all in the denominator. And then we're just going to use some algebra by combining our like terms. So I'm going to combine this 3 and this minus 1. And then I'm going to bring everything else along. And that's your final answer. The fun doesn't stop there. Let's go the other direction. Here we have the expanded form given to us and we're going to condense it. The first thing I'm going to do is take care of these coefficients. I'm going to bring them up as exponents. So I'm going to rewrite this as log base 9 of 2 to the third, log base 9 of 5 second. Because these are both log base 9, I can actually combine them together. So log base 9 of 2 to the third, which I know is 8, divided, since it's being subtracted, log base 9 of 5 squared, I can just make that into a divided by 25, which is what 5 squared is. The next one will do the same thing. They're all log base of 3, so I can put them together. First I'm going to do take care of this coefficient. So I can't do anything with that log base 3 of 12, but why don't we just do it at the same time? Since it is being added to log base 3 of 7, I can go ahead and combine those as a multiply. Let's simplify a little bit before we move on. I can take care of that 12 times 7 using my calculator. I know that that's 84. And I can also take care of the 5 to the 4th. That's 625. Because these are both log base 3 and my directions are to condense, since they are being subtracted, I can rewrite them as a single log with division. Not too bad so far. Let's do this last one where we're going from expanded to condensed. I'm going to take care of all of these coefficients first. I kind of just like to get that out of the way. I don't know if you're noticing this. So we'll write this as log base 2 x to the 1/2, log base 2 y to the 8th, log base 2 z to the 5th. From our exponent rules, we know that when something is written to the 1/2 power, that's the same thing as square root of x. From our log rules, we know that anything that has a division is written down in the denominator of, anything that has a subtraction is written down as the denominator in a division. So, because I have a subtract before this log and a subtract before this log, it's almost as if I distributed that negative across. They are both going to go down in the denominator of the division. So just to really reiterate that, anything that has a negative in front of it is going to go in the denominator when you're condensing, because negative implies subtract, and subtract when you're condensing turns into division. All right, so we did some expanded and condensed versions. Let's talk about when they give you the directions of solve. A lot of these often involve that jumping, that leaping across, or the simplifying rules that we have over here on the right. So just a refresher, you're going to be working with these most likely when you're dealing with simplify or solve. So let's take a look at this one. Doing that frog on a log thing, I'm going to start with log, jump, jump, jump. So I'm going to take this log form and turn it into exponent. So 9, jump over to the 1/2, jump to the equal sign, jump to the x. 9 to the 1/2 is the same thing as square root of 9 from our exponent rules, which is 3. Not terrible. I see here I'm asked to solve, and I'm going to go ahead and do my frog on a log again. Start with the base and jump all the way over. So 2, jump to the 4, equals y to the y divided by 3. 2 to the 4th I know is 16. And then now this is just an algebra problem. Has nothing to do with logs at this point. We're going to go ahead and isolate that y by multiplying both sides by 3. And if you notice on the last two, I had something equals something, so I was able to do that hop thing. Here I have something minus something equals something, so I got to simplify this a little bit first. I'm going to go ahead and add 2 to both sides so that I get my something equals something. And now I can do my leap. So starting with the base, I jump over and bounce back. Since I'm going from exponent to log, I have to write the word log, start with the base, jump to the 14, jump to the equal sign, jump to the x, and that's as good as it's going to get. Technically, in my calculator, I could plug in log base 3 of 14 and get a decimal answer, but most professors and standardized tests prefer to keep it in this exact form. Again, on the first two, I saw something equals something, and here I have something equals something plus something. So let's do some simplifying first using our condensed rules. I'm going to take that 2 and bring it up as an exponent. And these two things that are being added, I'm going to rewrite it as a single log being multiplied. Basically, if there is no log written, these have technically a base of 10. And if I raise these into the exponent of the 10, 10 log 10 simplifies and everything else drops down. But that should make sense just by looking at it, kind of like a matching. If I have log x squared equals log 2 times 3x minus 4, it makes sense that the x squared can equal that 2 times 3x minus 4. So it's logical. From here, it's just algebra. Nothing to do with log rules. I'm recognizing this as quadratic. You guys are probably sick of quadratic by now. We go ahead and we factor this. And I know that my two answers algebraically are 2 and 4, but what you need to do when it comes to logs, because there are restrictions on logs, is you need to plug each of these answer choices in one by one and make sure that they actually do equal what it's supposed to, because sometimes you'll get extraneous answers with logs. So you always want to check your work. On this next one, I want to get it to something equals something again. So I'm going to deal with my condensing first. So let's go ahead and bring that coefficient up here. We'll bring the coefficient on here. And this one doesn't have a coefficient, so we'll leave it as it is. And then I'll just write down what the right side is. Using algebra, 5 squared is 25. 9 to the 1/2 is the same thing as saying square root of 9, which is 3. Bring everything else down. Using algebra, I see that I have log base 3, log base of 3, and they're being subtracted, so I can get rid of each of those. Bring everything down. It should be logical that obviously 25 is going to equal x from matching, but the log rule would be to raise them into the exponent of the b, which simplifies and proves that that is our answer. A lot of algebra in these. Now, instead of solve, if we're given the directions simplify, we're still going to be using our log rules. By now you should recognize this log base 5 of 5 situation cancels, and this just drops down, and that is literally your answer. On this one, we have several ways we can do it. We can distribute that 1/3 across, or we can use our log rule of bringing the 1/3 in front. I'm going to stick with the log rules for now, just because I really want to drive that in. That 1/3 applies to the whole thing, so when I choose to go into the expanded form, I need to put parentheses so I know that 1/3 is applying to everything. You've seen this situation with the 8 before. I'm going to change that to 2 to the 3rd because this log base 2 of 2 cancels and I'm left with just 3. Let's bring everything else down. And then what we would do from here is distribute that 1/3 across. So we would have 1 plus 1/3 log 2 of x. And this is okay, this is simplified, not solved, but the directions were simplify. For this last one, to go out with the bang, I'm going to show you both ways. I'm going to show you how we will get the same answer, whether we use log rules or we use exponent rules to kind of start it out. So let's talk about using the log rules. If I was to simplify this, I'm going to use the subtraction situation first, because if it's division, 1 divided by 49 to the x, that's not 49 times x, sorry about that, we should turn it into subtraction with condensing. We have a rule way up above that says log of any base of 1 is 0. So this is technically 0. We also have that rule up above that log of any base of that same base to a power. The bases, the log base situation cancels. 49 is the same thing as 7 squared. So we have log base 7 of 7. So the 2x drops down, and that minus does as well. And that's your answer. Let's see how we could have done this with exponents as well. Log base 7, 1 over 49x. I'm going to go step by step. 49 is the same as 7 squared to the x power. A power to a power. Our exponent rules tell us to multiply. When it's in the denominator, our exponent rules tell us to write it on the opposite side with a negative exponent. And then from our log rules, we know log 7 simplify, and we're left with what was in the exponent. So it doesn't matter which way I go about this. And honestly, generally when you're learning logs and exponents, that's the trickiest part, is you're sitting in class and your teacher is going to do this a totally different way than you did on your homework, but you're going to get the same answer. So in many of these cases, even as I was working through them, you might have thought, but couldn't you do it this way? And by all means, give it a try. Try doing it your way. You'll find that you'll probably get the same answer. While that can make things confusing, it should also be empowering to tell you that you should be able to get the answer no matter which path you take. And that's pretty cool when you're dealing with standardized test questions or even just a chapter test, knowing I can go any path and I'm going to end up with the right answer. I'm going to include a link for this PDF below, so if you want to practice these again on your own or just want to have a sheet where all the rules are written out, you're welcome to print it out and hang on to especially this top part, which I have here, which has all the log rules written out. And I would suggest keeping that near your exponent rules, because recognizing that they're opposite each other, it's almost like a 2-for-1 situation. Learning one, you're remembering the other as well.